So we're starting off with trig because it's such an enormous section and carries so many marks. What I wanted us to do this evening was practice two of the concepts that generally always come up. The one is simplifying something to a single trigonometric ratio, and the other concept was working with a ratio in terms of a letter. So we'll get into that a little bit later. All right, so you're always, well, not always, but a lot of the time they can give you a question like this, like the one that's on the screen at the moment. And it says, without using a calculator, simplify the following expression to one trigonometric ratio. Okay, and believe it or not, even though this question is out of 6, it's done that way in order to be able to help you. So theoretically, something like this would be considered a level 2 sort of question. Okay, so something that would be routine, something you've seen a lot of times. And this is really an opportunity for you to try and get as many of those 6 marks as possible. All right, so what they've done here is that they have combined an angle X with some numbers as well. So we're going to have to do reduction, but we're going to have to work in terms of X, and we're also going to have to work in terms of an actual number angle. All right, so when we look at sine 140, what are we thinking? What are you thinking, Matrix, when you look at the sine of 140? What do you think you need to do with the sine of 140? Any idea? What should we do with the sine of 140? So Pumzile says 180 minus x. Good, Pumzile, good. Okay, so Lesejo, you've got to stick to reduction formulae. Okay, so you can either use 180 minus, 180 plus, or 360 minus. Okay, so Pumzile says let's use 180 minus. Pumzile, why? Okay, Luzo says what about 90 plus 50? Okay, you could do that too if you wanted to. That's also an option. What's the Luzo and Mamelo? If you did 90 plus, what do you need to be careful of? If you did 90 plus. That's it. Okay, so sine theta changes to cos theta, or cos theta changes to sine theta when we use 90 plus and 90 minus. Okay, so you are able to do that. That's not a problem. All right, but what I'm going to do with this, I'm going to go with Leanne's suggestion and Pumzile's suggestion, and then we'll see after that. You guys are right, though, we are going to have to use a co-ratio. All right, so the sine of 140 can be reduced to positive sine 40. Okay, because this is an obtuse angle. We're in quadrant 2. We've used the reduction formula 180 minus, so we know that sine theta needs to be positive. We've always got to be careful about whether our answers are going to be positive or negative. Okay, what happens to sine 360 minus x? What does that become? That's right, Mamelo. So 180 minus 40 is 140. So it reduces to an acute angle. There we go. Well done. You're all getting the right answer there. So this is going to reduce to negative sine x because we were working in the fourth quadrant where sine x is negative. Well done. Now we have the cos of 50. So I'm going to leave the cos of 50 as it is because it's already acute. And now we're going to worry about tan minus x. So what does tan minus x reduce to? That's it, Gugu. Well done. It's going to reduce to negative tan x because negative x is seen as going into the fourth quadrant. Okay, so now let's have a look at the sine 40 and the cos of 50. We know, Mamela, why is it sine 40? Okay, so it's sine 140. So you're rewriting 140 as 180 minus 40. Okay, so then when it reduces to an acute angle, it's sine 40. Okay. We can, Leanne, we can do that. What we can also do with the sine 40 and the cos 50 is that they're equal to one another. Okay, so the sine of 40 is equal to the cos of 50. Because they're co-ratios and it adds up to 90. So what you could do here is write sine 40 as cos 50 or write cos 50 as sine 40. And because we are multiplying, we can cancel something at the top with something at the bottom. All right, so a lot of the time people rewrite cos as sine, but it really doesn't matter. I'm going to leave this as negative sine x. And then at the bottom, I'm going to rewrite cos 50 as sine 40 as well. And then those will be able to cancel. And then what do I need to do with the negative tan x? What do I need to do with negative tan x? What should I do? Okay, when you say expand it, Amatle, what do you mean exactly? That's it, Gugu. Negative sine x over cos x. Good, well done. So negative sine x over cos x. Now, don't make the mistake of making both the top and the bottom negative. If tan x is negative, it means either the numerator or the denominator is negative, not both negative at the same time. Okay, so only one of them, only the sine x or the cos x must be negative. So now we can cancel something at the top with something at the bottom. All right, so sine 40 divided by sine 40 is 1. And now we've got a negative divided by a negative, right? So a negative divided by a negative is going to leave us with a positive. So we've got sine x, and we are dividing that by sine x over cos x. What do we think we need to do now? We could, Amahle, we could cancel the negatives. So I could have got rid of them in the second step if I wanted to. That's it, Nhlanhla. I'm going to tip and times. So maybe an alternative way of writing this for yourselves over here is that you could write this equals sine x divided by sine x over cos x. All right, and then we can clearly see what's in the numerator and what is in the denominator. Okay, Lesego, I'm going to ask you to, Yolanda, please will you just help Lesego? They don't understand how we got cos 50 as sine 40. Could you just help Lesego with that for a minute?
Yes.
Cool, thank you so much. Okay, and then we're going to tip in times. So we're going to keep sine x as it is. We're going to change the divide to a times. And that means we're going to put cos x at the top, and we're going to put sine x at the bottom. So what we're doing over here is tip in times, or keep flip change, whatever your teachers taught you all the way back in grade 8. Okay, and now again, because we are multiplying, we can cancel something in the numerator with something in the denominator. So the way in which you set this out is really important, Matrix. Can you see here what I've written in the green on the right? You can see by the way that I've put it, that I'm implying that sine x is in the numerator and that cos x is in the denominator. And again here on the left-hand side in pink, I've got my sine x in the numerator times by cos x in the numerator and sine x in the denominator. How you set things out really helps when it comes to fractions like that, so you can clearly see what's at the top and what's at the bottom, and then it allows you to cancel correctly. Okay, so our final answer in this instance is going to be cos x. So we have reduced it, or simplified it, should I say, to one trigonometric ratio. Okay, so in this case, cos x. So this question is out of 6 marks. What they like to do in questions like this is they like to give you lots of marks in the first step, okay, on your reductions. So there would be an accuracy mark on sine 40. There'd be an accuracy mark on minus sine x. Cos 50, they're obviously not going to give you a mark for, but they would give you a mark for negative tan x. Then in the next line, there would be a mark for the co-ratios. So that means writing sine 40 as cos 50 or writing cos 50 as sine 40 as we decided to do. There's always a mark over here when you apply an identity. Okay, so here our tan identity, writing tan x as sine x over cos x. So we can see here we've got 1, 2, 3, 4, 5 marks. I would imagine they're not going to give you any marks in matric for tipping and timesing, that kind of thing. What they would do is obviously just check that you got your answer correctly, and your last mark would be on the answer. Okay, are there any questions about how we would do 5.1? Are we all good? Okay, so Gugu, you've got to do that before you cancel. Okay, you've got to change sine 40 to cos 50 or cos 50 to sine 40. Okay, and then cancel something at the top or something at the bottom. Okay, Leanne, you said no. Ma'am, is it positive sine 40 or negative sine 40 at the bottom? It would be positive sine 40. Okay, remember 40 and 50 are angles in the first quadrant where all your trig ratios are positive. Okay, so it would only be negative sine 40 if you were doing something like cos sine 320, then it would be negative sine 40. Okay, or if you were working in the third quadrant. Okay. Yes, Gugu, what's your question?
Hi, ma'am.
Hi, Gugu.
So thing is, I've learned what I've learned so far from my maths teacher. She told us that you don't necessarily have to convert the other ratio. So I've always done it as like, since it's sine 40 over cos 50 out, I've always done it as like canceling both of them without having to convert anything because they both add up to a 90 degrees. So is that
Okay.
incorrect? Or
I wouldn't do that. I would do what I had done, because the thing is that the whole reason that they've given you this question is because they want to see that you understand that it's equal to each other. So the correct way to do it is to make either sine 40 into cos 50 or cos 50 into sine 40 and then cancel it. Absolutely. Okay, so you're not supposed to say it's only anything divided by itself as 1. Okay, so you're supposed to indicate. The thing is with maths is that you've got to show you're working. So, you've got to show that you understand things. I mean, another thing that they also don't like, for example, is like, let's say here you've got tan negative x. They don't want you to skip this step where you've gone negative tan x and then you've written it as minus sine x over cos x. They want to see all these steps to your working. All right, so it is important. It is important to show that. The thing is that it's going to take you 2 seconds to write it, and you don't want to lose any marks. Okay.
okay, ma'am. Thank you.
All right, no problem. Lesejo, you can't factorize because you've already got factors. There are no pluses and minuses. So you don't need to factor out the negatives. A positive times a negative is a negative, and a positive times a negative is a negative. There's no factorizing that can be done here. Okay, because there are no terms. They are factors. Okay, all right. We could potentially come back to that one. What I wanted to do though is go and have a look at a grade 12 sort of question with the sort of same idea. So that essentially is a grade 11 question, okay, which they could ask you in trials. And sometimes they do, but let's do one that has some matric identities in it. Okay, so now here we may need to do some factorizing, Lesego, because you can see if you look at the numerator, there's a plus in the middle. So you've got a first term over here, and you've got a second term over there. So now if we want to do any kind of simplifying, we probably are going to have to factorize. Okay, but if it's only multiplication and division, we're already working with factors. Okay, so jumping straight in, how are we going to write sine 2x? Can anybody remember without looking at a formula sheet? How would we write sine 2x? There we go, and thank you, Norwazi, as well. We would write it as 2 sine x cos x. Good. And now we are multiplying this with something else. So cos minus x, how is that going to reduce? Is it going to reduce to negative cos x, or is it going to reduce to positive cos x? Which one is it? Good, well done, guys. Okay, it's positive cos x. Excellent. Okay, now we've got our plus. Now we're going to look at our second term. Here we've got cos 2x. So now, without looking at our formula sheet, there's a number of different ways in which we can write cos 2x. Any ideas? Okay, Lebogang, why is it positive? Why does it become? Okay, because remember, negative x, okay, is when you go into the fourth quadrant. Okay, so you have to learn your grade 11 reduction formulae. All right, so minus x is the same as 0 minus x. So that puts us into the fourth quadrant where cos x is positive. All right, so now someone's made a suggestion with regards to Nawazi. You're saying we should work with sine. We could. All right, let's try that and see what happens. Now, cos 2x is going to become a binomial. No matter how I write it, it's going to become a binomial. So it's important here for us to use brackets because both of these terms need to be multiplied by that last bit on the end. All right, so the suggestion here is 1 minus 2 sine squared x, which is fine. All right, and now we're looking at the last bit, sine 360 minus x. What is that going to become? Sine 360 minus x is going to become positive sine x or negative sine x matrix. Good, well done. That's it, Lesego. It's going to become negative sine x. Beautiful, because we are working in the fourth quadrant. Okay, down at the bottom in the denominator, we have sine 180 plus x. That's good. Well done, Mamelo, Amahle, Terry, Amahle. Good. So at the in the denominator, sorry, we've got sine 180 plus x. This means we are in quadrant 3. So this is going to reduce to negative sine x. Is everybody happy with that so far? All good. Okay, lovely. So now we just need to tidy up our terms. We need to remove those brackets in the second term. So our first term is going to be 2 sine x cos squared x, isn't it? Because you've got cos x times cos x. All right. I'm going to leave the plus there for now. Now I want to expand my terms. Okay, so I'm working from the back to the front. So I need to multiply the minus sine x by the minus 2 sine squared x, and I need to multiply the minus sine x by the 1 as well. All right, so in fact, it was actually silly for me to write that plus there, because if I do minus sine x times 1, that's going to give me minus sine x. And then in my second one, I'm going to have a negative times a negative, so that's going to give me a positive. And then here, I'm going to end up with positive 2 sine squared x, like so. Okay, all over negative sine x. Does that make sense to everybody? Are we all good so far? Okay, so let me just read. Okay, so some thumbs ups. Okay, Amahle, can we cancel the minus sine x in the denominator, 1 in the numerator? No, Amahle, we can't, because we're not allowed to cancel over plus and minus signs. So if we want to do any kind of cancelling, we first have to factorize. Okay, Kumo, with double angles, how do you decide which identity to use? Well, Kumo, sometimes it matters which identity you use, and sometimes it doesn't. If you are working with an identity, so proving a left-hand side equals a right-hand side, choosing the correct form of cos 2x is important. It's the same when you're doing general solutions. But in a situation like this, I don't know that it would have mattered too much which one we would have used, because I think either way we would have been able to take out a common factor. What I think is important here is that we can see that in the numerator, we can take sine x out of every single term. Okay. Is it squared? Is what squared, Nhlanhla? Oh, sorry. Oh, sorry. Thank you. You're quite right. Yes, absolutely. This actually is supposed to be a cube. Beg your pardon, because it's sine squared x times sine x. So that would be sine cubed x. Yes, sorry about that. Okay. All right. Thank you, Nhlanhla, for picking that up. Okay. So now we want to get rid of this minus sine x in the denominator. All right. So what we could do if we wanted to was take a minus sine x out of the top. What that would mean, of course, is that we're going to have some sign changes. But then at least when we cancel, we can get rid of our negatives. So let's do that. Let's take negative sine x out of the numerator. Right? What would our first term be? What would our first term be if we took minus sine x out? There we go. Good, Nhlanhla. So it would be negative 2 cos squared x. Absolutely. Okay. So remember, Gugu, we've taken the sine x out. Okay, we've taken the sine x out as a highest common factor. All right. That's it. What would the next term be if we took out a minus sine x? Good, Nhlanhla, it would be plus 1. Okay, remember we've got to have sign changes. And again, if we took out a minus sine x at the end, what would our last term in the brackets be? What would our last term be inside the brackets? That's it, Nhlanhla. It would be minus 2 sine squared x. Oh, good, Mamelo, you're saying the same thing. Good, Amahle. Okay, so just be careful of the sign change there, Amahle. Okay, and negative times a negative has got to give us a positive. So it'll be negative 2 sine squared x. Well done. All right, everybody, this is great. Okay, over minus sine x. Okay, so even though we had a little bit of, not trouble, but we had to be careful when we were inside our brackets with the signs of our terms, at least now we can cancel the negative at the top with the negative at the bottom. So remember, we can't touch anything inside the bracket. That's off limits because those are terms, but we can cancel negative sine x with negative sine x like so. All right, and what we're left with here is negative 2 cos squared x plus 1 minus 2 sine squared x. All right, so now looking at this, I'm going to write over here now. What do we think we should do? What would you do with what was left? Any ideas? Yes, Lindelwa. So if you're cancelling minus sine x at the top with minus sine x at the bottom, it's going to give you 1. So it's like if you divide negative 3 with negative 3, you'll get positive 1 as an answer. Any ideas as to what we could do with what's left? So normally when we get to a stage like this, we probably have to use another identity. Lebogang, we can only get tan x or tan squared x when we're dividing. So if you divide sine squared x with cos squared x, then you can get tan squared x. Think about the 1. What could we do with the 1? I mean, there's another option as well, but what could we do with the 1? What could we do with the 1? What do you know 1 is equal to? Think grade 11. There we go. There we go. So sine squared x plus cos squared x. Okay, so we could introduce some like terms and we could simplify a little bit further. Okay, so what I'm going to do is I'm going to bring, well, it doesn't matter. If I write it as minus 2 cos squared x, then I'm going to write plus sine squared x plus cos squared x, because sine squared x plus cos squared x is equal to 1. Hold on, I'm just going to scooch over just a little bit. Okay. And then I'm going to put my minus 2 sine squared x at the end. There we go, Martha, quite right. Okay, so is everybody happy with that? So what I've done here is I've used my grade 11 identity. Okay, I know that sine squared x plus cos squared x is equal to 1. So I've just rewritten 1 in a different way, and that's given me some like terms to be able to work with here. Okay, because cos squared minus 2 cos squared x and cos squared x are like terms. I can combine them together. So if I've got negative 2 cos squared x and I add cos squared x, what is the coefficient of cos squared x going to be now? So when I combine these two terms together, those two over there, what's the coefficient of cos squared x going to be? There we go, negative 1. Good, well done. All right, so now I've got negative 1 cos squared x, and then I've got sine squared x and minus 2 sine squared x. So what's the coefficient of sine squared x going to be? It's also, yes, Ntlantla, that's where we're going. Okay, it's also going to be negative sine squared x. All right, now, Lesejo, this is what your teacher is saying when they want you to factor out the negative. We have two different terms. We're not multiplying minus cos squared x with minus sine squared x. This is a subtraction. Okay, so because we have terms, now we can factorize. And I don't know if the rest of you saw what Nhlanhla put on the screen, but he's absolutely correct. We would take out a factor of -1. That would leave us with cos squared x plus sine squared x in the brackets. And then we would end up with -1 as our final answer. Okay, that's it, -1, Gugu. Perfect. All right, so you can see the ones involving the grade 12 double angle formulae are a little bit more complicated than the grade 11 ones. Okay, but that's what we would do if they gave us something like that. Are there any questions? Anyone got any questions before we move on? Mamelo, you good? All right, cool. That's nice. How's everybody else feeling? Are we feeling good about this question? All right. Nice. Okay, nice smiley face there from Amatle. Thank you. Yes, Lesego, don't worry, you're not the only one. Okay, so we'll keep practicing all the way up until you write your final papers. Okay, this is not easy, I know. All right, you just got to do your best. Okie dokie, let's go and have a look at the next set of questions. All right, so what we could do is we could do another question. Then it means we may not have time to do all the ratio in terms of a letter, but I suppose that's not the end of the world. What I think I'd like to show you is this next question. And Nhlanhla, very good question. And Nhlanhla says, what if we had used 2 cos squared x on the first step? Okay, so Nhlanhla, let's just go back and go and have a look at what you've suggested. So we would have still ended up with the first term being 2 sine x cos squared x. Then over here, if we'd written this as 2 cos squared x minus 1, we would have ended up with negative sine x. So that would have been minus 2 sine x cos squared x, and then we would have ended up with plus sine x. You know what? If we had done that, we would have actually got to our answer a lot faster. Okay, because look here, Nhlanhla, I hope you're following me. The first term and the second term, can you see they're identical? It's 2 sine x cos squared x minus 2 sine x cos squared x. Those two terms would have actually cancelled one another out. All right, but they would have added up to 0. And then you would have been left with positive sine x over negative sine x, and you would have still ended up with -1 as your answer. Crazy, hey? Yeah. Good question, Nhlanhla. It's always nice to be able to think about how else can we answer a particular question. What do you think of that? Would have saved us a lot of working out, hey? And I mean, theoretically, they still have to give us all the marks because, but yeah, that would have saved us a lot of working out. Okay, so here, what they would have done is they'll give us a mark for our identity. Gosh, here they would have to give us a mark for that identity over there. I would guess in this case, they would have to give you a mark for removing the brackets and obtaining, Oh, you would have also got a mark for, sorry, the minus sine x as well. So that would have been 3 of the 5 marks. Then I guess once you've removed the brackets, probably an accuracy on the numerator, that's 4 marks, and then last mark over there. Oh, Unati. Don't worry, Unati. You know what? It's in the past now, and there's nothing that anybody can do about it. All right. So learn from these mistakes. At the end of the day, your trials mark is going to be condensed down to a small mark out of your final mark. Okay. It's the finals that are really important. And as long as you are learning these things now, and you're not going to repeat those mistakes in trials, it's going to be okay. All right. By the time you finish, I promise you, we would have done so much revision. You're going to be ready for those finals. Okay. So write this down, Unati. Make notes during our lessons here at Watobe of the things that you know that you got wrong. And then you can revise that and go over that again. Okay. All right. So I think I'd like to try this question with you guys because this involves, okay, maybe I shouldn't say what it involves, but let's do this one as well, and we can do ratio in terms of a letter a little bit at the end of the lesson. But let's have a look at this question. So here they want us to simplify cos x minus 180 plus root 2 sine x plus 45 to a single trigonometric ratio. Okay, so again, this is a grade 12 question specifically. You can see here I've got our compound angle formulae and our double angle formulae for us there straight away. Okay, so this one is a little bit more difficult than the other two. Let's think carefully about what we are going to do over here. So how would we deal with a reduction when they've got the x first and the minus 180 at the end? What would we do there? Okay, so Teddy is suggesting add 360. That's probably the easiest thing for you to do. Okay, so if you add 360 degrees, what would you end up with? You'd end up with cos 180 plus x. Okay, yes, Gugu, that's going to reduce to negative cos x. All right, so that's fine. Well done, Teddy. That's perfect. Plus, now ooh, what on earth is that I'm drawing? I'm supposed to be trying to write a root here, and it looks like anything but root 2. And now with the sine x plus 45, what do you think we should do here with the sine x plus 45? What do you think they're testing in that question? What do you think? It's on the screen at the moment. Little hint. What do we think they're testing with the sine x plus 45? There we go, Amy. Well done. Cool. So look everyone, what Amy said. She says compound angles. Good, Amy. All right, so here it is in front of us. We've got sine A plus B. Same story over here. We've got sine x plus 45. Okay, so they want us to expand that. Okay, and then multiply it by root 2. So what I'm going to do now is I'm going to use a big square bracket, and I'm going to expand sine x plus 45 using my sine compound angle formula. Okay, so this is going to be written as sine x cos 45. Sine keeps its sign, so this will be plus cos x sine 45. Okay, and then I'm going to close my hard bracket around that. Okay, is everybody okay with that? Does that make sense? cool. All right, so a lot of trig is recognizing it for what it is. Okay, recognizing your double angles and recognizing your compound angles. Okay, good stuff. Okay, so let's keep going. So now we've got cos 180 plus x, and I don't know if it was Amatle or Gugu, but somebody said that this would reduce to negative cos x. That's true. 180 plus x is the third quadrant, so this is going to reduce to negative cos x, like so. And we're going to keep this root 2 on the outside. And inside here, we're going to work with the first term and the second term. Okay, so now what do we know about 45 degrees, Matrix? What's special about 45 degrees? It's a special angle, quite right. Okay, so we know that we can write the cos of 45 degrees as root 2 over 2. And now, because the cos of 45 is a number, I'm going to put that at the front and I'm going to put the sine x at the back of that term. And then I'm going to do the same thing. That's it, Lebogang, it certainly is. I'm going to do the same thing over here. All right, so I'm going to write sine 45 is root 2 over 2. So again, sine 45 and cos 45 are the same. Okay, they co-functions. They add up to 45 degrees. They're equal to each other. So they're both root 2 over 2. And then over here, we're going to end up with cos x inside our brackets. Okay, we're going to bring our term down to the next line, our minus cos x. And this root 2 sitting on the outside that I'm busy highlighting in pink, it needs to be expanded into the bracket. Okay, so I've got to multiply it by the first term, and I've got to multiply it by the second term. All right, so now when I say root 2 times root 2 over 2, I'm going to end up with root 2 times 2 is 2. Exactly, so it will become 1. Okay, root 2 times root 2 is 2, and 2 divided by 2 is 1. So this is going to become plus 1 sine x. Good, well done. And then remember, I've got to expand it to the second term. So again, root 2 times 2 is 2 over 2. So this would be plus 1 cos x. Very nice. Okay, and now our minus cos x and our plus cos x will add up to 0. And what we are simply left with is positive sine x, like so. Okay. There we go. Everybody happy with that? Any questions? Gugu's happy, nice. All right. Good. Well done, everybody. Good, Lebogang. Good, blessing. Okay. All right. So let's just talk a little bit about where the marks would be before we move off. They would not give you a mark for cos 180 plus x. So they're not going to give you a mark for adding 360 at metric level. They will give you a mark for reducing those. So you'll get a mark on the negative cos x. You're always going to get a mark when you apply a compound angle formula or a double angle formula. Okay, so there's going to be 1 mark on what's written in pink over there. There's also going to be a mark on our special angles. So writing cos 45 is root 2 over 2, writing sine 45 is root 2 over 2. Then here, I imagine on this line here, it would be an accuracy mark on simplifying. So in other words, that you've multiplied both terms inside the bracket by the root 2 correctly. And then our last mark, 1, 2, 3, 4, 5, our last mark would be on our answer. Okay, so that's where our marks would be awarded in this particular case. All right, so let's see if in the last few minutes we can fit in some ratio in terms of a letter. Okay, so A question like this, ratio in terms of let me try that again. Ratio in terms of a letter looks like this. So we will be given something. So in this case, cos 35 equals m. Again, without using a calculator, determine the value of each of the following in terms of m. So these sorts of questions are related to our Pythagoras question. However, when we are working with Pythagoras, we could work in the first, the second, the third, or the fourth quadrant. Because 35 is an acute angle, we are working in the first quadrant. So what we really should be doing here is we should be drawing a diagram. Okay, so our terminal arm is over there. Whoopsie, put it down. Our terminal arm is over there. We are supposed to label this angle at being 35 degrees. Martley's already done the first one. Okay, Martley, just hang tight before you answer the questions. We've got to draw our diagram. And now we have to do an interpretation. The cos of 35, the cos of any angle, is always going to be x over r. So m means m over 1. So they are implying that the x coordinate is m, because remember we're working in terms of m here. We don't know what our y coordinate is just yet, and they're also implying that r is equal to 1. So before we answer any questions, I suppose we could do the first question, we can't do the second question. Let's first get ourselves ready and work out what y is in terms of m. So this is what we do. We do the theorem of Pythagoras. So we say m squared plus y squared equals 1 squared. Okay, and that's theorem of Pythagoras. And now y squared is the subject of the formula. So I'm going to make, so 1 squared is 1. And then I'm going to bring my m squared over from the other side. And now I'm going to take my square root. So I'd get the square root of 1 minus m squared. Because I am working in the first quadrant, y is going to be positive. Okay, but that's just because this is an angle that is 35. Okay, remember when you're doing theorem of Pythagoras, you always have to be careful about which quadrant you're working in because x and y change sign. Okay, but with ratio in terms of a letter, we are working in the first quadrant in this case. So now we've got our variables x, y, and r in terms of m. Okay, so x is equal to m, y is equal to root 1 minus m squared, and r is equal to 1. Okay, and now we can answer any of the questions. So in 5.2.1, because 215 is an angle in the third quadrant, they first want us to apply a grade 11 reduction formula and to try and use that 35. So we won't get a mark for this, but we can write the cos of 215 as the cos of 180 plus the angle they gave us, 35. Okay, that's what they want. Okay, so because we are in the third quadrant, this would now reduce to negative cos 35. Okay, so the cos of 35 is equal to m, so our final answer would be negative m. That's at negative cos m. Okay, so Lindelwa, I'm going to get Yolanda to help you. Yolanda, please will you assist Lindelwa? I think she
Lindau.
didn't. Yes, Lindelwa, I don't think she understood what I was doing here in the pink. If you could
Okay.
just assist her with that, please. Thank you so much. Okay, so we didn't need the diagram for the first question. Let's work on the second question. Now here we've got the sine of 20. Okay, so when we look at this, there's no obvious path for us between the sine of 20 and the cos of 35. So now we really have to start thinking. All right. So my question to you is, how else can we write the sine of 20? Start there. What else? How else can we write the sine of 20? Let's see what you guys come up with. Ah, all right. Very nice. Gugu, straight off the mark. Okay. Nhlanhla, straight off the mark. Co-ratios. Excellent. Well done. Okay, so often in these questions, they use co-ratios. That's really good. Well done. That's it. Nice. Good. You guys are making the correct connections here. So the sine of 20 is the same as the cos of 70. And the cos of 70 is the cos of 2 times 35. All right, so now we can see that first it was a co-ratio, and then it was a double angle. So now we can work either in terms of cos or we can work in terms of sine. In fact, now that I'm thinking, we actually probably didn't even need that working in the pink there. If we wanted to use sine here, then we could. But let's write this as 2 cos squared 35 minus 1. Okay, so we actually didn't need the working thing. We normally do, but in this particular case, we didn't. But it's just good to do that anyway, right? Because invariably you do need it. Okay, so cos 35 is m. So this is going to be 2m squared minus 1. There we go. All right, so our 2 marks in the first question would be on the reduction to negative cos 35 and the answer. And then the 3 marks in the third question, 1 mark on the cos 70, 1 mark on the 2 cos squared 35 minus 1, and 1 mark on in terms of m. Okay, are there any questions? Oh yes, please do the poll before you go. I never remember. Yolanda always has to slip it in there. Oh, thank you, Yolanda.
Any questions, guys? You're still okay? Okay. Looks like they understood, Teacher Lee. Good thing.
Okay. All right. Good stuff, everybody.
Oh,
Yes, we're fine. Just a bit stressed. Okay. Lebohang is making sense. Understand now. Also. Okay, Leanne, can you get back to the previous question so I can screenshot? I certainly can. That's fine. So you mean this question over here, Leanne, the one on 5.2? You understand. Okay, Unati. All right, you've just got to keep practicing. Okay, so screenshot these questions, go away, don't look at the answers, and try and work through them again. Remember, all of this is always going to be the application of what you guys know. All right, so you've got to go and think about your compound angles, your double angle formulae, and bring that into whatever you are doing. Okay, they're never ever going to ask you something that's outside of the syllabus. Right, so it's always going to be something that you've seen and been exposed to.